I'm Mr. Kangas, and today we're going to be taking a look at Chapter 4, Section 2. The first thing I want to talk about when it comes to Chapter 4, Section 2, which is the chapter title is Prime Factorization. The first thing I want to talk about is what is a prime number and what is a composite number. You have primes, and you have composites. Prime numbers are numbers like 13, 2, 5, 31. These numbers have factors of only 1 and itself. So in other words, the only numbers that divide into 13 evenly are 13 and 1. The only numbers that divide into 2 evenly are 2 and 1, and the only numbers that divide into 5 or 31 are themselves and 1. Composites are numbers like 9. 9 is divisible by 1, 3, and 9. Or the number 8, which is divisible by 1, 2, 4, and 8. So another way to look at primes and composites is that primes only have 2 factors, 1 in itself. Composites are any number that have 3 or more factors. When you're finding prime factorization of a number, such as 32, it's important to understand what prime factorization is. I think a lot of people learn how to find prime factorization using a factor tree, but they never really understand what prime factorization is supposed to be. Prime factorization is, well, let me start here. Every number can be found by multiplying prime numbers together. So every number has a group of prime numbers that when multiplied together will equal it. So for example, with 32, if we do a factor tree to find the prime factorization of 32, we start by thinking to ourselves, what are 2 numbers I know that multiply together to get 32? So we're looking for 2 factors of 32. They don't have to be prime at this point. They will end up being prime. So I know that 8 times 4 is 32. So I've branched the 32 into 2 directions. I know that I can break 4 down even further. Into 2 times 2. At this point, I have 2 prime numbers in my factor tree. 2 cannot be broken down any further because 2 is a prime number. Its only factors are 2 and 1. So I can't break that down any further. So at this point, I'm going to circle the 2 2's I just got, because those signify the end of these branches. Once you hit a prime number, that branch has ended. The 8 can be broken down into 4 times 2. And once again, I've reached a prime number, so I'm going to circle it. That 2 signifies the end of this branch. And lastly, this 4 can also be broken down into 2 times 2 The branches have ended, as they now consist of prime numbers, and I have no more branches to break down. What I have are 5 prime numbers, 5 2's in this case. If we do 2 times 2 times 2 times 2 times 2, we get 32. So these 5 2's being multiplied together are the prime factorization of 32. They are the prime numbers that, when multiplied together, will get you 32. Another way to write 5 2's being multiplied together is 2 to the 5th power. When writing prime factorization, it is preferred that you combine common numbers and use exponents to represent them because it saves space. This is much more efficient use of space, writing 2 to the 5th power, than writing out 2 times 2 times 2 times 2 times 2. So one more example using regular numbers of how to find prime factorization. Something without so many 2's. Oh, let's try 36. I know that 9 times 4 is 36. I know I can break 9 down into 3 times 3. 3 is a prime number. These 2 branches have ended. So I'm going to circle those numbers because I know that they will end up being part of my prime factorization. 4 can be broken down into 2 times 2. Those 2 branches have ended. My tree is complete. I'm now going to circle the last 2 prime numbers on my tree. So if you take a look at the circled numbers, they're all prime, and together they represent the prime factorization of 36. So to get to 36 using prime numbers, you would multiply 3 times 3 times 2 times 2. 3 times 3 is 9, times 2 is 18, times 2 is 36. To condense this, or to make this smaller, we would write 3 squared times 2 squared. When finding prime factorization, it is crucial that you always remember to do the factor tree. A lot of times I've noticed students trying to use division to find the prime factorization. That's not how you go about it. Use the factor tree. It's the easiest, most effective way to find prime factorization. In the next video, we'll talk about how to find the prime factorization of monomials. So numbers that have variables with exponents on them attached to the end.